Hi guys, and welcome back to the ACE Academy. In this video, we will be looking at manipulating the shape of the natural parabola. Now in the previous video, I introduced you guys to the natural parabola, which had the equation y is equal to x squared. And the only difference between the equation of the natural parabola and the natural linear function is the fact that x is now squared instead of x being to the power 1, right? Now here's a question for you guys. What would happen if I multiplied the value of x squared by some whole number? How would that affect the shape of my parabola? Now that's the little investigation that we're going to be doing here in this video, and I hope you guys pay attention and pick up a thing or two from this video, and I hope it makes it a bit easier, right? Like I said, the equation for the natural parabola is y is equal to x squared, right? Now what would happen if I said y is equal to 2x squared? So the only way for us to gauge the difference or the change in shape by multiplying the x squared by 2 would be for us to plot this function, right? So we're going to go ahead and we're going to start plotting this function. If we substitute 0 into this formula, we would get 2 times 0 squared, which would be 0. So I'm going to locate the x value of 0 and plot the corresponding y value of 0. Then we would move on, moving towards the right, substituting the point 1 for x, we would get 2 times 1 squared, which would be 2. Now substituting in the point 2, 2 times 2 squared, 2 squared is 4, 2 times 4 would be 8. I can go ahead and plot the y value of 8 to the x value of 2, and that would leave me somewhere over here, right? And that is the maximum that I can reach for this particular Cartesian plane on the right. Now if I'm moving towards the left, substituting in -1 into our equation, that would be 2 times -1 squared, which would leave us with the value of 2. Okay, and if I substitute in the point -2 into our equation, that would be 2 times -2 squared, which would be 8. So what I've done is I have sketched this function by joining all the points that we have plotted, and we have obtained a new function. That would be the blue function on your screen right now. Now, the only difference in shape that we can see for this particular manipulation would be the fact that the function is constrained. It becomes thinner and thinner the higher you multiply, the higher the number is that you multiply x squared by, right? And that gives us a much skinnier function. Now what if I were to say y is equal to a half x squared, right? So let me go ahead and plot that and write down that equation for you guys. Okay, so if I were to plot this function of y is equal to a half x squared, I would obviously do the exact same steps that I did previously. I would substitute in my x values from the x-axis, and I would plot the corresponding y values to them. So starting off at 0, 0 squared is 0, a half times 0 is 0. So that's going to share the origin point, right? If I substitute in 1, 1 squared is 1, a half times 1 is a half, right? So I'm going to plot that there. 2 squared is 4, a half times 4 is 2. Okay, 3 squared is 9, a half times 9 is 4.5. Four squared is 16, and a half times 16 is 8. Okay, and if I do the same thing to all my points on the left hand side, it would just be mirrored, of course. So for an x value of 2, my y value would be 2. For an x value of 3, my y value would be 4.5. And for an x value of -4, my y value would be -8. Okay, and now if I'm going to plot in or draw in this function, joining the dots, I would be left with something that would look like this. So that would be the yellow function that is on your screen right now. Now what we can see here is that when I multiply the equation of the natural parabola by any whole number, we can see that the function itself takes a shape that is much more skinnier. But when I multiply the equation of the natural parabola by a number that is a fraction, right? We are now expanding the width of the parabola. We are making it more wider, of course, right? Now, this is a little trick that would come in handy for you to understand functions a bit better as you move on to grade 11 and 12, okay? Now, the next significant manipulation that I want to discuss with you guys is when I multiply the natural parabola by a negative integer. So what I'm going to do right now is I'm going to plot the function of y is equal to negative 1x squared, right? This can also be written as y is equal to negative x squared. It's the exact same thing, okay? Now, if I'm going to plot this, I would get 0 squared would equal to 0, and if I multiply 0 by negative 1, I'm still going to end up with 0, right? If I multiply 1 squared by negative 1, I would end up with negative 1. 2 squared is 4, multiplied by negative 1, I would get an answer of negative 4. Right. 3 squared is 9, multiplied by negative 1, I would get an answer of negative 9. If I'm working towards the left, negative 1 squared is 1, multiplied by negative 1 would be negative 1. Negative 2 squared is 4. 4 times negative 1 is negative 4. Right. Negative 3 squared is 9, multiplied by negative 1. That would give me an answer of negative 9. And if I draw this in, I would obtain a shape that looks like this. So, the thing that I want you guys to take away from this little exercise is that when I multiply the natural parabolic function by a negative number, I'm essentially flipping it over the x-axis. It's a reflection about the x-axis. I obtain a sad face parabola. Now this is extremely important, as soon as you receive an equation for a parabola, you'll be able to gauge whether it is a smiley face or a sad face parabola, and that will assist you with all of your parabolic functions in grade 10, 11, and 12. Now the last thing on the agenda for today would be, of course, the standard formula for this type of situation, and that would be y is equal to ax squared, where a is the whole number that we are multiplying the x squared by to obtain the new function, and a is the shape of the function. That's it from me, guys, and all the best. I will see you in the next one.